Hello, Math Studies students. Welcome to another online lesson. We're continuing our unit on two-variable statistics, talking about chi-squared. And today is the day that we're going to show how to use technology, or our TI 83 or 84 calculators, to find a chi-squared value. We're also going to talk about something called the p-test, or a p-value test, to determine independence, which is the same thing that chi-squared helps us find. To start with, I'm going to show you the steps necessary in order to find chi-squared on a calculator. So the first thing we always have to do is get data into the calculator when we are doing any sort of statistics on the TI. So we take our observed data. That's all we need. We enter our observed data into a matrix in the calculator. Now, a matrix is something that looks like a little mini spreadsheet. You studied it probably sophomore year in advanced algebra or algebra 2. And that's what we'll be using here. So I'll show you how to get to that, but you just go to a matrix key on your calculator, which on most of them is second and then inverse, and then you go to edit, and that'll allow you to put in your data. Then we just go to perform chi-squared test, which you get to going to the stat menu once again, going to test rather than calculate. It's a test. So that's a little different. We've never gone there before. And then you select the chi-squared test, and then you select calculate. And that's it. It'll even give you the expected values, and I'll show you how to retrieve those in just a moment. But those are your button entering operations. First, go to matrix menu, edit, put in your matrix information. Then we go to stat, test, chi-squared test, and calculate. The p-value is one of the values that will come up for chi-squared. Now, when we talk about chi-squared, we usually want to have a lower value. The lower the value, the more likely we are to accept our null hypothesis, which says they're independent. So if we want them to be independent, we need a low chi-squared value. P-values are the opposite. P-values are nice, though, because they actually use that. You don't need a critical value. All you need is your significance level, 5%, which turns into 0.05 on a calculator. It's the opposite. If your p-value is greater, p stands for percentage. If your percentage is greater than 0.05, we accept the null. So we're using a greater than. So p needs to be big in order to accept. Chi needs to be low in order to accept. P we compare to the significance level. Chi we compare to our critical value, which we get using a degree of freedom and significance level. Again, we reject our null hypothesis if P is less than whatever percentage we're using. Again, usually 5%. So if it's less than 0.05. However, if we were testing at 1%, you would change both of these numbers to become 0.01. Or if we were testing at 10%, 0.10 would be a 10% or any other percent there. And so in many ways, the p-value test is way better, I would argue. It's simpler, it's more refined. The reason that I focus more on the chi-squared is the chi-squared is the one that we need to learn to do by hand. The p is much more straightforward. So let's go and take a look at an example of this. I'm going to show you how to do the chi-squared, get that value, as well as showing you how to get a p-value and test that. So on your worksheet from last class, we had this data here. It dealt with people deciding whether or not they wanted an increase in the speed limit versus their age. So comparing those two variables. Again, if we accept our null hypothesis, there's no relationship. And that would happen if our chi-squared value, as it turns out, was bigger than 5.99. That was our critical value for this. So according to my directions, the first thing we want to do is go to the matrix menu. You'll start by pressing the second key, which is in the upper left-hand corner of your calculator, and then going to the inverse key, and you'll notice the second function there is matrix. So if I tap that, I'm now at the matrix menu. So second, and then the matrix key, which is the inverse key. And then I arrow over to edit, and I select my first matrix. Right now the order is 3 by 3. That's rows, then columns, like RC, remote control, radio control, or Royal Crown Cola, or RC. So rows first, we have 2 rows of data, increase and no increase. And then we have 3 columns, which is the 3 different age groups that we have. And now we just enter in these numbers from left to right. So 234 is our first amount. And then 169 was our next piece of observed data. 134, and now I go to the next row, 156. You'll notice I'm just hitting enter and it automatically goes from left to right, top to bottom. 191, and then 233. Double check to make sure you put these numbers in correctly. There's not a lot you have to do here, so make sure that the math you do, or at least the numbers you enter, are correct. And mine look to match up perfectly at the moment. So now we're going to quit out of this screen. You can press second and the mode button, which is right next to it, which is quit, second quit. Now what we're going to do is go to the stat menu. I'm going to arrow over to tests. And we've got all kinds of tests, z-tests, t-tests, SAMP T, SAMP Z, Prop Z, all these things. Honestly, many of them I've not used, though I've heard people refer to them in their psychology classes and their biology and chemistry classes. It might be something you'd want to look into if you're in one of those classes. A little Google search would tell you how to do any of these. But we're going to do the chi-squared test, which is the C option. And the first thing it asks is, where is our observed data? It defaults to matrix A. Matrix, they use the little brackets in the capital letter. We put our data in the first matrix, which was matrix A. Now, when it says expected, for a long time, I always thought that I had to put my expected value in and calculate that by hand. That's not what it's saying. It's saying, where do you want it to put the expected data? It'll put it wherever you want. It'll default to B. So if you have something already in matrix B, it's going to go away if you tell it to put matrix B there. If you want to change this, you would go to the second matrix key again, and then under this first column here where it says names, just select whichever matrix you want it to put the information into. I like it going into B, so I'm just going to select that. And again, we now have my expected data going into matrix B. You want to calculate it. We don't want to draw it. So again, it defaults to everything that we need. You can just press enter, enter, enter once you go to chi-squared test. No lists to worry about. And I press enter. Voila, it gives me a chi-squared value of 42.057, which rounds to three significant figures at 42.1, which is what the answer should be that you got on your worksheet from last class. So our critical value, and notice they even give us the degree of freedom being 2. And if we're testing at 5%, we can go look that up on our critical value table that I gave you last class, and is also on our book and the last slideshow. And we can see that our critical value would have been 5.99. Remember, for chi-squared, it's like golf. We want the score to be as low as possible in order to pass the test and accept our null hypothesis. Well, this chi-squared value is 42.1, which is way more than our critical value of 5.99. So we would not accept our null hypothesis. We would reject our null hypothesis. And there is a relationship going on between these people's ages and their desire to increase the speed limit. So that right there is the chi-squared test using the calculator. You still need to get a critical value off of the table or some other way. Maybe it'll be given to you on a math problem, but you still need to know the critical value. And then again, you're just comparing the chi-squared to that critical value. The p-test, notice we have a p-value here. Well, be careful. This p-value is not 7. It's not 7%. It's going to give you a decimal, and the decimal, again, anywhere between 0 and 1. This value, notice that there is some scientific notation going on, e negative 10, which means I need to move this decimal place 10 times. There's a lot of zeros. So this p is especially tiny. It's less than 1%. It's less than 1/10 of 1%. Heck, it's less than 1,000th of a percent. It's 0.000000736. Which would translate into, as a percentage, a point with, I guess, about 6 zeros in front of the 7. And I may have gotten one zero off there, but that's the idea. This is a tiny little number. So for the p-test, what we do is we compare it to our significance level. We're testing at a 5% significance level, and it's the opposite of chi-squared. In order to pass our test, we need to have a percentage greater than 5%. Is our percentage greater than 5? No, it's way less than 5. It's less than 1. It's less than, a very tiny, tiny bit. So, do we pass the test? No, we do not. So it's twice where we failed it. We failed it from the p-test. We failed it from the chi-squared test. And again, you'll always get the same results for them. They're testing the exact same thing. It's just that one of which is a little bit more streamlined, that p-test. So on our actual IB exams, you're expected to know both. You're expected to know how to interpret a chi-squared value. You're expected to know how to find degrees of freedom, all of that good stuff. But you're also expected to know how to use a p-value test. And again, p-value, if it's greater than the percentage, meaning if the p-value that they give us, that percentage value, is greater than this percent after we do our decimal conversion, we pass the test, meaning we accept our null hypothesis, no relationship. but otherwise we reject it. So ladies and gentlemen, that is independence, chi-squared and p-value tests using technology. Next class, we're going to do an activity in groups dealing with making a poster. I might also start talking about our IB projects, either next class or the following. And that's where we're at for now. So until next time.